Hello everyone. So in this discussion we are going to talk about cyclic group subsets. That is, we are going to work on subgroup of a cyclic group, and we are going to say that every subgroup of a cyclic group is cyclic. So we are going to work on the proof part of the subgroup of a cyclic group is cyclic theorem. For this reason, let us choose capital G as a cyclic group generated by small a. Let H be a subgroup of G. So that this is a continuation of the previous discussion. So already we have seen any cyclic group is abelian, and to the next level we worked on certain things on how the generator works in a cyclic group. Now we are going to claim that if H is the subgroup of capital G, then H is a cyclic group if it is a subgroup of a cyclic group. Okay. Clearly every element of H is of the form a power n. Okay, since it is a generator there or some integer n. So since H is the generator, even in the subgroup the same work happens. Okay, then only we can call it as a cyclic group. So a power n is the format of the elements in the subgroup H. Okay, so in the next level, so let us work further. Okay, let m be the least positive integer such that a power m belongs to H. Okay, so let m be the least positive integer such that a power m belongs to, that is the generator a power m belongs to H. So we are going to claim that a power m is the generator of H. In order to prove that, let us take B, an element belonging to capital H. Then since all the elements are of the generator format in the cyclic group, then we can say B is equal to a power n model. So B equal to a power n for some integer n. Now the integer n can be written as n is equal to m q plus r. Already we have worked on certain concepts like division algorithms on those areas. So you can very well understand on seeing this. N is equal to mq plus r, where q is the quotient, r is the remainder idea, and r lies between 0 to m, where r is the remainder. So B can be written as a power n, and since n is equal to mq plus r, we can write a power mq plus r. So when you split the base, you can write a power mq into a power r. So now you can write a power m whole power q. So this could be rewritten as B is equal to a power m whole q into a power r. Now what I am doing is I am bringing the a power m power q to the other side. So I get a power r is equal to a power m power minus q into B. So let us assume this one as equation number 1. Okay, so we are going to further work on this theorem. So now at present I take a power m belongs to H. Okay, a power m belongs to H. So what happens, since H is a subgroup, so from where we take, from the cyclic group. So since H is a subgroup, we can take a power m, that is it's a generator model, a power m whole power minus q belongs to H. Okay, so since here you can clearly understand H is a subgroup, that's why we take a power m power minus q belongs to H. Also we know that B is also taken as an element of H. We have earlier taken B belongs to H, and we are telling here that B is equal to a power n. So now what we understand here is, from equation number 1 we can say a power r belongs to H. Since all the right hand side belongs to r, we can say a power r belongs to H, where 0 lies between, that is r lies between 0 to m. So what we could say here is m is the least positive integer. Okay, we are taking m as the least positive integer such that a power m belongs to h, such that a power m belongs to h. So here we get the clear understanding of how we have to proceed, what the structure we have to maintain. Okay, since we have taken m as the least positive integer such that a power m belongs to h, we can say r is equal to, r is nothing but the remainder, so r is equal to 0. So you can write b is equal to a power n, which is equal to a power m cube, and since r is 0, a power 0 is 1, so a power mg is equal to a power m whole power g. Okay, so here this claims that every element of this particular subgroup, okay, every element of the subgroup H is a power of what? A power m model is a power of a power m. So this is what we understand by the derivation what we have. If you go step by step and you see, it is very clear to understand here, and hence what we can say is H is a cyclic group. Okay, H is nothing but a subgroup. Now once after this derivation we have clearly understood that H is a subgroup.